Hello, welcome to the video lessons on learning, teaching, and applying geometry and handling data. My name is Malik. We're going to begin our lessons with Unit 4, which looks at vectors and what? Bearings. And our objective of this lesson is to define a vector quantity, define a scalar quantity, distinguish between scalars and vectors, and look at the various representation of what? Vectors. What is a vector? A vector or vector quantity is any quantity which has both magnitude and direction, right? What do I mean by magnitude and direction? For instance, if we are in class and you come to me that you don't know the principal office, therefore I should show you how to get to the principal office, and I say, okay, when you get out of the class, walk 50 meters. I mean, is that enough for you to get to the principal office? Because you are going to be confused. When I get out of the class, how do I just walk? Do I just walk straight or walk to the right, walk to the left? Because I just say 50 meters, right? But if I say when you get out of the class, turn left and walk 50 meters. That one is enough for you because immediately I get out of the class, I turn left and walk 50 meters, right? So any quantity that gives you direction, which is left, turn left, it means giving you direction, and gives you the magnitude. Usually, the word magnitude simply means either the length or size, right? So I've given you how to walk, how long you're supposed to walk. That's 50 meters. And I've given you the direction. So any quantity that has both magnitude, which is the length or the size, and has direction, is referred as a vector. For instance, force. You have a table and you want to push the table, and the force you are using to push the table is, say, 20 newtons, and you are pushing it left. That's why we say, okay, force is a vector quantity because it has both magnitude and direction. Acceleration. If you are riding your motorbike and you are moving, say, 5 meters per second, right? And you are moving all the way to the north. So it gives you both your magnitude and direction. But if I have a quantity, we say a scalar or scalar quantity is any quantity that has only magnitude and no direction, right? This particular one has only magnitude, like length. If I just say, okay, the length of the ruler is, say, 5 centimeters. It has no direction. If you go to buy a bag of rice and it say 5 kg, that's just the weight or the size of the rice. So there's no direction. Basically, if I say the temperature is, say, 40 degrees Celsius, it only gives you the magnitude. It doesn't have direction, right? So let's move on. It says vector representations. How do I represent a vector? Vectors are denoted by capital letters and an arrow on top of them. For example, vector OA. Instead of writing the whole word vector OA, you write it as OA in capital, then an arrow on top. This represents the movement from O to A in a given plane, where O is the starting point, meaning you are starting from O and your final destination is A. Now, how do we represent vectors? We say we can represent vectors in column or component form or magnitude bearing form. So we can say, for instance, if I have vector AB, I will say vector AB is equal to 2, 3. This is the column or component form. Or if I say vector AB is equal to the magnitude bearing form, this one, the R represents your magnitude and the theta represents your bearing. So I will just say, okay, 5 kilometers, and then the bearing is, say, 30 degrees. So this is the magnitude bearing form, and this is the component or column form. All right, let's move on. We say graphical representation of vectors. For vectors in the column form, that is A and B, A is measured along the x-axis. So the A at the top represent x, value that are found on the x-axis, and then the b represent value that are measured around the y-axis, right? So for instance, if I have vector AB and it's equal to say 2 and 3, then when I go ahead and draw a Cartesian plane, right? If I draw a Cartesian plane, I know this is my y-axis and this is my x-axis. So what we're saying is, then the 2, if I want to write 2, I know on the x-axis, these are the positives, these are the negatives. On the y-axis, these are the positives, these are the negatives. Therefore, if I want to represent this number or this vector on it, then 2, I have to move 2 units on the positive part of x. So 2 units, I'm just going to write 2 here. And then on the y, I'm moving 3 units, just 3. That's how you represent it, 2 and 3. And then in the next lessons, I'm sure we are going to do various representations and you are really going to understand what I'm saying. All right, so let's move on. It says, for vectors, remember we just looked at vectors in the column form. We want to look at vectors in the magnitude and bearing form. For vectors in the magnitude and bearing form, that is the r and the theta, the magnitude r shows the length of the line, whilst the bearing theta shows the direction. For example, I have 13 units and 337 degrees. Note, all bearings are measured from the geographical north. Arrowed lines represent vector quantities in a diagram, right? And we say the length of the line represents the magnitude and arrow shows the direction. In the next lesson, we are really going to demonstrate it, and for you to really understand what I really mean by just these words. We are really going to throw more light with the diagram representation. Thank you for taking your time to watch this. See you in the next lesson.